Greetings and welcome to a quick lesson on network architecture equipment, right? So what are the equipment that gets an network to work? So the first thing we're going to go over is home, right? What do you have in your home that makes your network? And then we'll go into business after that. But the first thing is what most people call a modem. Really, it's a residential gateway. And really, pretty much ISPs have been giving these out because they're a modem and the broadband router, so they get the information in and out. But they also do the NAT, which I think I talked about last lesson. Have security features, a little bit of a firewall access. Most people don't do any of the configuration that they have, but they do have more configurations. And then lots of them even now just come with Wi-Fi built into them, so they're the one-stop shopping. Resident gateways, and that's what you're going to kind of see with your home-based network architecture. Is pretty simple. The internet plugs into this. You might have a device like this that plugs into a device like this, and this straight here just does the modem part of it, a little bit of the routing, right? And then this just does the internal like switching, gets to your devices. You can plug in directly, or you have the wireless feature. So sometimes they have two, but a lot of times nowadays this one device has it all in it, all the features. But at the very least, again, you'll have the modem, broadband router, and then it might connect to another device. Right? This is where the internet comes in, and then you have the local area network, Wi-Fi, and hardwired, which kind of brings us to this concept of wired versus wireless, right? Most residential gateways we talked about like both, but you might have two separate devices. And it kind of looks like this, right? The internet comes in, goes to the device, and then you're wired to computers, which means you have to run a wire, which is the downside of that. But they are more reliable and fast, right? You can send more data over it. Don't have to worry about it getting slower the further away you are from the device. Which is, this interference as well can slow these down. But it's flexible, right? I mean, I don't need to carry a wire around, right? It'd be really irritating if you had to plug your phone directly into your residential gateway to get internet, right? So wireless versus wired. Again, most devices can do both, but that's what it is. Again, especially as far as we look at home. But as we move on to business, on the other hand, there's a lot more wired, and we're not even going to get into a whole lot of the wireless in this lesson because there's a whole system of that. But we're going to talk about some of the main equipment pieces for this, which being the hub. And if you're lucky, you don't actually have any of these in your business, but all it does is it copies the ports and just it splits them. So it's a splitter, but doesn't really do any switching or anything, right? It gets the internet in. This is what this picture's showing, right? The internet comes in from this port, and it goes to all of them, right? It's dumb, right? You might call it a dumb switch, but it doesn't know, so it sends them out, right? One internet connection for all of them. They still get their own IP addresses, but when this sends it out, it's going to send it everywhere. There's nothing smart in this. It knows, hey, if I'm talking to this printer over here and I'm this computer, I should go this way. No, it's going to send it all out to everything. And then basically what happens is the protocols just ignore anything that's not to them, right? That's how this is able to work, is the computer's protocol just says, hey, look, all this is coming to me, that's not mine, so I ignore it. Now, on the flip side, a switch is a smart hub, right? Whereas the internet comes in and it goes to what it needs to go. So like this is internet from the outside, it realizes it needs to go over here, and this one's like, hey, I just want to talk to this computer over here, right? So it knows I'm not even going to send you out of the network to get into this. So it takes many inputs, and you might see these switches have 40 or more devices. You can stack them, and again, they're smart, right? They know where it needs to go. And then there's the router, right? And one way to look at it is routers connect switches. They connect two separate networks and says, hey, it's not on this network. I need to send you over to a different set of switches to get you where you need to go, right? So usually LAN to a WAN or whatever. One might think like your building has its one router or so, to get to other buildings, but everything inside of that building might be again, just depends on how they configure it, but it might be just switches. And that way the buildings have the routers that can route to each other if they need to. But if it's just in the same building, they just the switches kind of make sure they get to the right spot. So we're going to watch a quick little video that shows a little bit of this switching and whatnot, and kind of follows a path. It does go a little bit past what we're doing this lesson, but it's kind of interesting how you can actually see a little bit of traveling inside the network before it goes out. But it does a little bit of review from other concepts that we've learned. Greetings. Welcome to a quick little video showing a little bit of routing. Right. So what we're going to do in this is the command prompt. We're going to run a command called trace route. Trace RT is the command, and we're just going to go to google.com. Now again, this is going to navigate through my network at the school district, so you're going to see and navigate through switches and routers and then out onto the internet. So this is a good introduction to kind of see how this works, with also how the internet works, how can local internet providers want to keep stuff on their network as much, but again, even just kind of bounces around in the network. So with that, we'll go ahead and click that. Again, this is DNS, right? Google.com. And we had to go out and actually find its IP address, because as we're going to see, each of these are IP addresses as we're bouncing around, right? So just going to quick glimpse into DNS, and then as it's going through, this is the local switch, which sends up to the local router, which is all in the building, and then it sends it to another building. Again, remember, they kind of connect the networks across. That's when they become routers. But the first one is a switch, moves it along, and then as we go through the rest of this, you'll see it's basically on Charter and Spectrum. Same thing over here, and basically bouncing up along. So this is probably the local router. You got Kennewick bouncing around, Seattle. I believe this is where it's leaving the Charter network and then getting to its final destination. So you can see quite a bit. A trace route is a nice, useful tool. See how things work, where we just talked about what routers and switches and all those fun things are. So with that, good example of kind of following those routes across the internet, IP review, DNS review, all that good fun stuff. Hope you enjoyed the video. All right, so welcome to a quick let's go ahead and move on to the next slide real quick. And the last couple one device and then a concept we'll go over for you to understand about the devices that make up the network architecture. Is the firewall, and it sits at the very edge of the network. So normally you got a router right behind it, and it passes through. So this would be the router. It's the one that does the traffic, but it sends it through, right? And the key to this is, see all that red, right, is all this traffic's trying to get to you, and this blocks it. And there's all kinds of different layers. We're not going to go into every single different type of firewall there is. But a lot of the times you just block certain protocol, block certain IP addresses. Some routers are smarter and they can actually see the packets coming through and say, hey, this packet, we don't want it to go through, this file that we don't want to go through. So, I mean, downsides are, if you have a tunnel through like a VPN or something, it's kind of hard to do a little higher level packet filtering and whatnot to get to work. But again, there's a bunch of rules essentially that you apply to the firewall that don't let traffic in, and also on the flip side, don't let stuff out, right? So maybe you got compromised and you don't want certain files to exit out, right? So you can still block certain like file servers from actually going outside the network, right? So there is other things you can do, and we'll talk about more in security about firewalls and segmenting the network and whatnot from a security standpoint. But this is a device, right? Normally this is a device that businesses have. One useless fact of the day, is this concept. See how data gets smaller? Well, that can also be effective. Even if that is good data, is this bottleneck concept, right? If your firewall can handle 100, can handle a gigabyte, but your router is capable of 2 gigabytes, your internet connection is 2 gigabytes, right? You effectively have 1 gigabyte. So again, you need to make sure that all of your equipment speeds are the same, routers and whatnot, especially at this higher level. And then once it splits off, it's not as important. So like, for example, school district might have 10 gigs coming in, and then 10 gigs to each school. Then once it's in the school, that only goes out a gig because there's so many devices there, it's not really an issue. So those are firewalls in a nutshell. Again, another good device. And then this last one is a concept. It's not actually a device, but some devices have this. And it's power over Ethernet. And basically, those cables that connect you to the internet, you can also send power over them with the right switches and cables and devices. But a couple examples are, instead of having to have a power cable to plug into your phone, the phone can run right over the Ethernet cable, right? It provides enough power to run a phone. Normally, a network type phone, if you've ever seen those before. And then also cameras, right? Because if you have a camera that's up on a wall, you don't want to run 2 wires to it everywhere you have a camera. And the same concept with phones, right? You don't need to, if you can run the power directly over Ethernet, that works. So these are key concept devices that are used for network architecture, designing of what you might use for network architecture. But it's important to understand what they are, what they do in a broad sense. So with that, that's the end of this lesson. Have a good one. We'll see you next lesson.